Hello, ladies and gentlemen. It is me, Ivan, your host. Welcome back. So, in the last episode about the asteroids and also about the moons of Mars, it was really interesting, right? The possibility of an asteroid hitting Earth, all those things, just very, very interesting. But today is not that topic. We'll also talk about Jupiter and its moons. So, Jupiter is known as the largest planet in the entire solar system, and it's also known as the most massive. How is it so massive? Why is it so massive? Why and how is it so big? And why is it in that specific orbit? Why does it hold to all these moons? All these whys and whys and whys. We're going to answer all this in today's episode. So please buckle up and let's get started. As I just said, Jupiter is the largest planet in the entire solar system, and that's why it is given its name, after the Roman king of the gods. And trust me, that being given the king of the Roman gods is just an understatement to the true power of Jupiter. Jupiter is so big that you could fit 11 Earths across its diameter. But not only that, you can fit more than 1,000 Earths inside. Plus, to just give you a little more perspective on how massive and how big in terms of volume Jupiter is, if you could put all the planets inside Jupiter, you would have a lot of room to spare. Now, let's get into the features of Jupiter. Now, Jupiter is actually a gas giant. That's the special name we give it. Since it's a gas giant, it's mostly made of gas. In fact, the most abundant gases in the atmosphere of Jupiter is hydrogen and helium. Like the sun, of course. Now, what makes it so special and indistinguishable from all the other gas giants is its stripes, its bands in the atmosphere. Why are there these bands? Now, let's first label them, shall we? Right. So take a look at this picture of Jupiter. You see there are dark parts, some darker parts, and there are also these white, lighter parts. These darker parts are called zones, and the lighter ones are called belts. Have we memorized that? Very well. Now, over the years, we have seen that these zones and belts keep changing in color, and sometimes some of them disappear. Look probably in this photo. You see there is a specific belt, a specific zone rather, which you could see very clearly. But later years, that zone has disappeared and now it has reappeared again. You see, it's very strange. And it's not just those beautiful patterns and stripes in its atmosphere. The very fact that it has no place to land is very surprising and very mind-blowing. Just to give you a perspective, if you could fly in a jumbo jet across the atmosphere of Jupiter, you would never land. There is no land for you to stand on. And now, do you remember these pictures about the layers of the rocky planets? Do you remember them? That Venus, Mars, all planets have these layers. All those rocky planets, they have a mantle, a core, and a crust, isn't it? And the sun also has a core, we know that now. But does Jupiter have a core? Very interesting. Does it have a core? For several years, we have asked ourselves this question, and we are still asking this question today. But the leading answer is a fuzzy core. So it's neither solid, it's neither liquid. It's just fuzzy. A much typical example is, instead of the core of Jupiter either being molten like magma or being solid like iron, it's actually like a bowl of chili. There's characteristics of solid and characteristics of liquid. It's just in that kind of mixture. And thus, it maybe have a fuzzy core. Or maybe it has no core at all. We're still wondering that question. And speaking of core, let's talk about the other layers of Jupiter. So now, the very interesting thing about Jupiter is as you go deeper and deeper, the pressures and temperatures of Jupiter start to change its properties. For example, if you start from space and you're diving deep into Jupiter, so you start seeing, okay, we're still in the gaseous part. You go from the outer atmosphere to the inner atmosphere, and then as you leave the inner atmosphere, you enter in a part of Jupiter which is liquid hydrogen. Can you imagine? Liquid hydrogen. And as we get deeper and deeper, hydrogen no longer acts like a gas, but more like a solid. And thus it becomes metallic hydrogen. And this is a revolution in all chemistry and physics. For a long time we thought that hydrogen cannot be converted into a liquid or even metal. But since then, we have discovered that it's actually possible in the universe. Now, let's get into how it formed. After the core of Jupiter built up, the gas accreted, making the modern today Jupiter as we know and love it today. So, as you have seen in that simulation, Jupiter started probably as a rocky planet, who knows, and then the gaseous part, since it was in the outer part of the solar system, the gas around it, since it was building up gravity and mass, it started to feed. It started a feeding frenzy of gas, accreting gas more and more, building up the atmosphere, all the layers, pressures and heat building up until we have this beautiful gaseous planet we see today. Now, let's go into one of the most iconic features of Jupiter, the strongest, the biggest tornado in the solar system, the Great Red Spot. This Great Red Spot was first spotted by Giovanni Cassini, and that it means it was so big you could actually see it with a telescope. And since then, it has been actually still active. In fact, since the time of Giovanni Cassini, this Great Red Spot was still active. Imagine a tornado active for more than 300 years. Can you imagine this? That's what we're wondering. Or is it even older than 300 years? Did it form before Giovanni Cassini observed it? Interesting, right? But now, let's end with one of the most surprising features of Jupiter, its heat. Now, when you observe Jupiter, we can't stop observing that Jupiter releases more heat than it receives. So, since it receives the same heat from the sun, you might think that it will actually radiate away the same amount of heat. Much more like the Earth does. Wrong. It actually releases more heat. Remember, just take a look at this. Take all the heat it receives from the sun, plus the internal heat being produced by the pressures of its atmosphere in the core. So in other words, the heat that is radiated away from the core is coupled up with the heat radiated away, comes from the sun, and then you have much more heat than it received. This is a very, very complicated concept, but then, yes, that's how it actually works. But now, let's talk about Jupiter's moons. Jupiter's moons are more than 70 or even 80 in some cases. But then, let's talk about the 4 Galilean moons. Okay, so we know in the history of astronomy that Galileo Galilei has contributed to many things, relativity and motion, but he also contributed to discovering the 4 Galilean moons. The very reason why they called these moons Galilean moons is because Galileo discovered them in 1610. That's how bright and how big they are. Here are their names: Ganymede, Callisto, Io, and Europa. Let's run through this very quickly. And we're going to discuss this in future series. Ganymede, the largest moon in the entire solar system, is approximately 5,270 kilometers across. Much more like the moon, it has cratered parts of its surface. Some parts of its surface are very heavily cratered, thus meaning they're very old, and smoother and younger parts of it. The strange thing is this: we see some dark grooves and bands on it, which might be due to some carbon compounds rising due to the tidal forces from other moons, which we will discuss. So, the second biggest is Callisto, which is approximately 4,800 kilometers across. That's approximately as big as Mercury. Now, it's no different from its brother Ganymede, but it also has a magnetic field. The same for its brother. So, in more similar ways, Callisto is no different from Ganymede. Finally, the third biggest is Io. Now, Io has an incredibly weird surface. It is yellow and green and black and orange. What is the meaning of this? Just take a look at this picture. It's very weird. Why? It's because of the sulfur released in the volcanic activity. Speaking of volcanic activity, we have seen that Io is the most active body in the solar system. It's incredibly geologically active. It has more than 400 active volcanoes on its surface. And it also has a magnetic field. And so, since its magnetic field, just like Ganymede, is magnetically connected to Jupiter, we can actually see sulfur particles in the magnetic field of Jupiter, and we can see them in the form of aurorae, probably like this one on its north pole. So, I hope that at least you remember this, that Ganymede and Io are magnetically connected to Jupiter, and we can see their magnetic footprints in the atmosphere of Jupiter. And now, the most interesting of the Galilean moons is Europa. Europa has an icy surface, and surprisingly enough, it has no craters, unlike other moons. Why does it has no? Means why don't we see any craters on the surface? The reason why we don't see any craters on the surface is probably because it was resurfaced. But if it was resurfaced by geologic activity, we would see rocks. But instead of rocks, we see ice. In other words, it must have had a resurfacing from liquid water. What? Yes, you guessed it. There is probably a sub-ocean under the icy crust of Europa. And NASA is even thinking of sending a mission there and searching for life in the sub-ocean of Europa. And how can it be so warm? Well, the same applies. Tidal friction causes the water, the ice in the sub-layers of Europa to melt and become salty and watery, salty liquid water. So, to just conclude, let me give you a recap so that you can at least get it better. So we have got today that Jupiter is the most massive planet in the solar system. It has the most moons, and frankly, it releases more heat than it receives. And most importantly, Io and Ganymede are magnetically connected to Jupiter, so we can see its magnetic footprints in the atmosphere. And Io is the most volcanic planetary object in the solar system. And finally, Europa is having probably liquid water under its surface due to tidal friction. So I hope you really like this video. Please click the like button, subscribe to my channel, and support me on my Patreon page. Thank you.